Hi everyone. So I was here earlier when I talked about smart contract security and smart contract auditing. And now I want to talk about blockchain security beyond smart contract audits. And I've just realized this really long title, when I came up with this really long title, that wasn't my best moment. But anyway, here we are. It's anything to do with blockchain security, which is not in a smart contract. So for those that haven't, that didn't listen in earlier, quickly about me, who I have a background in distributed systems research, and then moved into cybersecurity. I'm now the CEO of Cryptonics, which is a Spanish company, and I'm also the lead auditor of SOLIDIFIED, which is a US company. And I specialize in smart contract audits and full stack blockchain security. And Cryptonics as a company focuses just on this blockchain security in general. We perform security audits and pen testing of whole decentralized applications. And we also provide consulting for blockchain protocol and cryptography. So when we do blockchain consulting or security consulting, the obvious question that comes up is, are blockchains secure? Are they a secure platform to build an enterprise-grade application or a decentralized application? And the answer is, well, blockchain protocols use cutting-edge cryptography, right? Like these elliptic curves, which I've drawn here, even though I'm not going to talk about elliptic curves. But you know, they illustrate the type of cryptography we use. And we currently think that this type of cryptography is unbreakable, at least with current technology and what we expect to come up in the next few years. So if the cryptography is so secure, why do we get these cases put recently here? Some are not that recently, but just a few examples of things that happen, right? So Monero, asset cryptography is secure in a blockchain. Monero is a protocol that prides itself on really good privacy-preserving cryptography, but they had a huge incident a while back where the private keys from the official wallets were stolen, and of course that had nothing to do with cryptography, but it's an incident that affected their platform. IOTA, whatever I think of IOTA, it's a large network, and last year it was down for whole months after an attack. So that's obviously catastrophic for a project, a whole month of downtime. Due to a security incident. And most recently, we are getting a lot of DeFi protocols incidents, and I talked about this before if you've seen the talk. But it's estimated that more than $200 million were stolen in 2020, and of course that's just an estimate. We don't know the real number, but there's a lot of security incidents going on. So why is that? And to explain the problem of security, I like to go back at explaining the major use case of blockchains, and this is really the underlying concept that all decentralized applications build on, and it's digital ownership, or ownership of digital assets. And this is very basic maybe for this audience, but I think it's a good way of stepping back and thinking about what we're actually trying to achieve and where the security issues might occur. So basically we have an asset, right? Like this painting here. And that asset might be, well, a painting in the real world, or something of value in the real world, or it might be something more abstract, a new asset class like Bitcoin or Ether, or some token, or it could even be something even more abstract, like an identity, right? But it's something that is of value to someone, and that's represented on a blockchain, and the blockchain in turn runs on a peer-to-peer network. And on the blockchain, this is really just a number, right? So this asset is represented in some form of token, which is a number or a smart contract containing numbers and identifiers, right? But it's really just something that represents something else. And the interesting part is that there's a cryptographic key that controls this representation on the blockchain. And this cryptographic key is controlled by a user. And that's what we generally use to model ownership. And every decentralized application basically builds on this very simple concept, right? So if we look at the potential attack vectors here, we've obviously got the blockchain protocol, which we've already said is secure. Now, obviously, that's not entirely true. There are incidents where the blockchain protocol itself is compromised or attacked. But in general, let's just assume that the blockchain is secure and the cryptographic protocols work. Then we still have to worry about our representation of the asset on the blockchain. That's a smart contract or the token or whatever abstraction we use. We have to worry about this cryptographic key that controls the asset, and that has to be kept safe. And we have to worry about the actual infrastructure everything runs on, right? And finally, we have to worry about the user that has to interact with the system, because that's also potential to mess up, right? So if we translate this into security concerns, we come up with this simple classification of 5 major concerns. So there's smart contracts, there's key management, there's off-chain code, there's infrastructure, and there are humans involved, right? So I'll talk a little bit about each of these in turn. But one thing to note is that the only thing blockchain specific really here are smart contracts and key management. Of course, key management also exists in other types of application, but in general, it's more relevant in blockchain applications because everything is managed by a key, as we've just shown in the previous slide. And the other thing that is slightly different, or at least there's a different impact, is the human interaction, right? Because decentralized applications have empowered users. They control their own keys, they control their assets, they own their data. They can do stuff that other users in a more centralized application cannot do. And there are other ways of messing up for the user than there are in traditional centralized applications. So if we look at these, so I've talked a lot about smart contract security before, so I won't say much about it now. But basically, smart contracts have 3 main properties which ensure that they work and do what they're supposed to do. And that's they're publicly accessible. They usually hold a value. Obviously, there are smart contracts that hold no value whatsoever, but they're not very useful. I think normally we represent value. And they're immutable, which means we cannot fix bugs, right? Obviously, there's upgradability and these things. There are tricks around this, but in general, anything on the blockchain is immutable. And these 3 properties combined turn smart contracts into an ideal target for cybersecurity incidents. And that's all I want to say about smart contract, really, apart from obviously get your smart contracts audited. I spoke before about how we do that and what type of things we discover. But yes, through SOLIDIFIED, we do provide a lot of smart contract audits. But there are other things to look at. And the next thing to look at is all the off-chain code, right? These are databases, websites, APIs. And they share the cybersecurity concerns of traditional software, right? There's nothing new, but a lot of cybersecurity incidents happen in traditional software. So we have to look at all this. And these are common incidents, right? We can have insecure authentication. We can have erroneous use of cryptography, right? Cryptography protocols are only as secure as implementations. Many libraries can be used incorrectly or might even have implementation issues, bugs. And we can have key storage exposure, which is sort of related to key management, which we'll talk about later. But in general, software vulnerabilities and backdoors, typical cybersecurity things. And to bring up a quick case study here, let's look at the last year's IOTA wallet attack, right? So I said before, the protocol was down for whole months. And that was due to the official Trinity wallet, which is the main IOTA wallet at the time, was compromised, right? Basically, the users had their private keys stolen from it. And when I say private keys, I mean the seeds that generate the private keys, but it doesn't matter, right? The keys were compromised. And it led to a whole month of downtime, which is obviously incredible. But the reasons for this were nothing to do with any of the IOTA cryptography or the IOTA protocol. It was just to do with the supply chain attack, right? A very traditional, well, not so traditional, but a common software security type of attack. And basically what happened, a third-party component within the wallet that was replaced in the build process by someone who managed to trick a content delivery network into providing a malicious version. And they basically replaced a library or a plugin or whatever you want to call this, a module of the wallet, which was a third-party component. And that sent the keys to a compromised server or sent the keys to a command and control center. So sophisticated attack, but nothing to do with blockchain, right? To do with build pipelines and software supply chain. The same goes for infrastructure, right? We have node software. A blockchain needs to run on nodes. These nodes are implemented in software. They can be faulty and can have bugs. Everything runs on a network. There are APIs involved. Permissions can be set wrongly. A lot of things can go wrong. And we've seen that a lot in vulnerable node software. The Bitcoin core software has been compromised a few times by security vulnerabilities. Same happened with different implementation of Ethereum node software. Operating system security can be an issue. and there's network security, which can lead to things like denial of service attacks, Eclipse attacks, and we can have exposed APIs like the JSON RPC port being left open on Ethereum node. That's a classic. That type of thing happens. So what's the solution to this? Well, it's to get your off-chain components audited as well. And that's something we provide at Cryptonics. We do look at the whole stack. We look at infrastructure, we look at software, we look at the build chain pipeline, we look at supply chain, we look at APIs, we look at everything. Right? So that's one step further in auditing. You can go beyond the smart contract audit. Key management is obviously very important. Users manage keys in blockchain applications. There are also privileged accounts which have privileged keys which are critical. Keys are stolen and keys can be lost, and that causes all sorts of issues. And we need to have a strategy in place to deal with all this. Right? So the first part of key management is obviously how to store keys. So for storage, you can store keys in a software key vault. One step further, you can rely on a cloud HMSM. HSM is a hardware security module. Obviously, if it's in the cloud, it's someone else's hardware, but it's still it's a component that locks keys inside and they don't leave there. And obviously, you can use a real HSM, a local HSM. The most simple example would be something like a hardware wallet, but there are more sophisticated industrial-grade key management solutions for bigger projects. And obviously, then you have to worry about how you use these keys. So you can come up with multi-signature procedures. You can have logging of who has used which key when, especially when you have enterprise blockchain solutions where you might have shared keys for different roles in the company. And you have to have a policy in place on how these keys are issued, how they're roked. And what a lot of companies forget, or a lot of projects don't have in mind, is have a protocol in place when a key gets compromised, right? Because you have to be able to act quickly and deal with this. And if you have a protocol in place, that's much easier. So what's the solution to this? Well, again, it's to get your key management audited, right? We do that quite frequently. We look at wallets and we look at things like we do audit a lot of cross-blockchain bridges where keys have to be stored, usually multi-signature keys. Sometimes there are centralized bridges with trusted execution environments, but there's always some sort of key management involved, and we audit these. Very important. Then the last One is the human factor, right? And the user, the human, is really the weakest link in the chain. And every cybersecurity analyst will tell you this. The user, if you have a human in the system, you really have a problem. And users are generally lazy. They take shortcuts and they do things you don't expect, right? It's impossible to foresee all potential user interactions with your platform. And they will get tricked into using the wrong user interface, and they will blame the project. They will get tricked into giving their keys away, and they blame the decentralized application they are dealing with at the time for this. And there are other things related to users, like, who are your developers? Do you trust them? Who deploys your smart contracts? Can you really trust them? Especially in this decentralized, distributed way of working we have, where you might be working with people on the other side of the world that you've never met in person. And you might have subcontracted someone with an alias, you don't even know their name. And, backdoors by developers is a classic example of how things can go wrong. So another case study of how humans can be the target was in 2019, the big hack of the Binance exchange, right? So in May 2019, Binance lost $40 million in BTC from different user from different hot wallets, and it belonged to different users. And they sorted it out in the end. The money got back to most of the users, we are told. But it was a significant hack, a significant attack. And the interesting part was that all the accesses were through the API. And they also had the two-factor authentication tokens for withdrawals. And we don't know the whole story there because there's some confidentiality involved, but the post-mortem seems to indicate there was a very sophisticated phishing attack that managed to get hold of these API keys and the 2FA tokens. So that was quite sophisticated social engineering, and the attack vector was clearly the end user. A very good example of how users can be attacked at a large scale. And the solution here, this might sound a bit silly, but you can get your humans audited, right? By this, I mean, of course, we can look at security policies. We can look at, how you deal with your internal protocols related to users, how you communicate with your users, how you advise users to do certain things, how you set up the user experience for the user to make less mistakes in terms of security, and what fail-safes you have in place, right? So that's a very important type of audit, which goes way beyond the actual technical implementations. It looks at policy. So related to this, before I end, I want to talk about a couple of resources we have. One thing we've been working on with a consortium of companies is the Enterprise Blockchain Security Specification, EBSS. Now it's aimed at our enterprise blockchain clients, but it's really applicable to any type of blockchain-related application, and it's a high-level security specification. The idea is not to compete with best practice advice on how to implement your smart contracts or cryptography, or even ISO-style standards for IT security. It's to add. The idea is mainly to add best practice and policy guidelines for privacy and cybersecurity at a high level, right? To blockchain projects. And there are 23 requirements in 5 domains. The link is here. It's open source in the sense that while it's on GitHub, you can add by providing a pull request. You can make suggestions. And you can also join the consortium if you are a company interested in blockchain security, and obviously you need to have something, to add to this consortium. But in general, we are open to anyone taking part. So please, if you are interested, get in touch. The other resource we've recently launched is a blog called Blocksec, The Art of Blockchain Security. And it's an independent resource on blockchain security. So this is not our company's blog. Right? First of all, it's a collaboration between Cryptonics and SOLIDIFIED in terms of, in that we host it and we we pay for the hosting and we sponsor the blog. But other than that, it's an independent resource, and we don't have that much content on there yet because it's fairly new. But I think the content that is on there is fairly good, and we also value guest contributions. So if anyone has something interesting to contribute in terms of an article on blockchain security or blockchain privacy, anything related to this space, please get in touch with me. The submission guidelines, because we're just starting, are very simple, right? You need to pitch me a good idea, and basically anyone can contribute anything. And obviously it has to pass some filter of basic quality, but we help with the editing. But generally, we are open to any type of contribution. So yeah, please get in touch. And that's about it. I started a bit early and finished a bit early as well. So I suppose I have more time for questions if there are any.
Okay, the first one is for Guilherme. Are your audits based on any security standards such as ISO 27001?
No, they are fairly blockchain specific, and well, yes and no, right? So we don't provide any audit certificates that state that you comply with some ISO, but a lot of our auditors have ISO experience, and they apply their knowledge from these type of standards to the auditing, but we are not an official provider for certificates related to these ISOs, and we also think that there are certain things that are only relevant to the blockchain space, which is why we came up with this enterprise blockchain security specification. And we also work quite closely with the cryptocurrency certification council, I think it's called. I forgot the name, but I'm part of the cryptocurrency security auditing standard there. I'm in the committee defining it, and we do work closely with them for auditing, but no ISO.
Okay, another one from Stefan. Which wallets have been already audited for those issues?
Well, we've audited sort of the built-in wallet of a lot of proprietary enterprise blockchain applications, and we've recently audited the wallet of the Morpher platform. That audit report is actually going to be published tomorrow, I think, but we conclude the audit, and it's public knowledge that we've done that, so I'm not giving anything away. And yeah, but we haven't audited MetaMask or anything like that.
Okay, another one. Crypto Alpha, it's asking, where can we get more info about security audits for dApps? I'm interested.
Yeah, I mean, so the best way is to head over to our website or contact me on well, there's my Twitter account on here on this slide. But I'm generally relatively easy to find, you can the best way is to talk to me directly.